Write down first. Graph y equals x minus 2, or x minus 1 over 2, quantity squared minus 3. Now, could I just graph this in regular Cartesian mode? Could you graph this?
Yes.
Yes, you could. Yes? But I want a little practice of putting it in parametric. So here we go. What does my function depend on? It depends on x. Does everyone agree with that?
Yes.
So I'm going to let x be t. But then if x is t, then y is t minus 1 over 2 squared minus 3. Yeah?
Yeah.
Now, we do not know what t is between and between. If you're not told, we're going to assume negative infinity to infinity. So let's grab our calculators. And first things first, we need to figure out how to change the mode on these calculators. Give you a hint, you go to your menu.
Oh, it's
Go away. Did we find it?
wait, should we be in graphing? Or?
You can go home. You can calculate. Or you want to go to settings. It's up to you. I would go to settings. Remember we found this yesterday?
If you go into
You can go to the file menu. Yeah. Same thing. Where do I go? Document settings. We were just there yesterday. Doesn't look like that's our radian. That's not where we change our mode. Now let me go back to graph where I was to begin with.
graph and it's in
I was gonna
graph
say,
entry,
it's in our
you have
graphing
parametric
commands.
mode.
Hold on. Come on. Go away. Let me go back to my graph because it was there.
It's in graph entry.
Actions.
No, graph
Three.
entry.
Entry.
Number 3.
Oh, 3.
And then that parametric.
There we go. There's our different types. Okay. Got it? So I want now parametric. I want 3. And it sets me up. What do I want x to be? Well, I want it to be t. Alright? Go down. I want this to be, let's see. Put in a real fraction. Oh, go back. Come here. Oh, it just deleted it all.
Bah.
Come on. Okay, so what was it? T minus 1 over 2. And that was squared. Was there more?
Minus 3.
Minus 3. Now, I don't want you to enter yet. Let's check that out. Do we want t between 0 and 6.28?
No.
Which, by the way, what did it set it as? What is 6.28 about?
That's
2 pi.
That's 2 pi. Okay, so it's automatically set as 0 to 2 pi. We don't want that. So we're going to go down and change that. And we can't put negative infinity to infinity, but we can put like negative 10 and 10, very least. And if I don't see the whole graph, I can change that.
What's T?
Oops. We'll get there. You're one step ahead of me.
Yeah.
T is your step size. Remember how when we picked t values when we graphed the other one, I went by whole numbers?
Yeah.
You don't want to go by whole numbers. Yeah, that gave me very few points. You want to go by something tiny. I always leave my t-step at 0.1. That'll give you a nice, neat curve. If you have a whole number there, it's not going to give you a good graph. It's going to give you something similar like it's going to connect the dots kind of thing. Okay, because it doesn't have that common sense we do. Now I can hit enter, and I see the parabola I should see. Right, because we know it should be parabola. Now let's say I only saw part of a parabola. You know something's wrong. What would you have to change? Your parameter, your t values, correct? So if you only saw part of it, just make your t go further out. Yeah, you with me? So this one I knew was a parabola. I knew I could graph this, but let's do another one. Cartesian equation? Try to get y by itself. You can't, correct? Now, you could technically do a lot of work, and we could complete the square. You y by itself? Probably been a while since you've done that. Okay. But we could complete the square, but we don't really need to. We can graph in parametric mode. This is exactly what we do later on in the year. I have to know what this graph looks like later on in the year, so I'm going to graph in parametric mode. But first things first, what is your independent variable? Y. So let y be t. Then x will be t squared minus 3t plus 1. Okay. We're going to assume t goes from negative infinity to infinity. So let's graph it. Okay. So I'm going to let x be, help me out, what was it? X squared or t squared?
T squared minus 3t.
Oh, and I wrote squared. 3t minus plus.
Plus 1.
Plus 1. I want the next one to be t. And it's going to change that back every time. Which
You might be able to change the defaults.
what's that?
You might be able to change the defaults.
I don't want to. Because I do want my trig here in a second. That's Monday stuff. Most of it is in trig. Okay. I'm going to change my step size to 0.1, and I could leave that 1.3. It doesn't really matter. Voila. And that should make sense, because look at your equation. It is a quadratic, right? So it should be a parabola, but it just depends on y. So it should be sideways. Now, is this a function? No. Before this, have you been able to graph things that weren't functions? No, a little polar, right?
Can we do positive and negative?
Yeah, that's the only way you can do is to do pieces. Okay? But the really cool thing about parametric mode is we can graph some awesome looking graphs. For instance, one of my favorites is, we have obviously not a function, right? And think about that. How would you graph that in Cartesian equation? You'd have a million pieces in your piecewise, wouldn't you? It'd be a disaster. It'd be a huge project. That would take a long time to graph. But in parametric, it's just one step. There's also things, there's like, they call it like a witch's heart or something. You can graph a heart in parametric mode. It looks really cute. You can graph the Batman symbol. I've seen that before too. Don't make me draw that. But really cool stuff. That we can graph these complicated, they're not functions, but we can graph these complicated equations in just one step instead of breaking up into a million pieces. Yeah?